Okay, welcome everybody. Welcome to the Unity beginner tutorial for the autumn 2021 quarter. Um, this might sound a little different. If you were there in person, this might sound a little different. That's because it is because I actually messed up the recording, and so I'm re-recording everything just for you guys. Hopefully, this is a lot cleaner. But let's get into it. So, first things first, open up your Unity hub, or just open up your Unity, I guess, and I'll pop this up. Yours might look a little different than mine, but it'll have basically the same features. So what we're going to do is we're going to open up a new project. We're going to select 2D. We're going to make a 2D project, and then name your project something like 2D Endless Runner. And you can just put it anywhere on your computer you want. I've already gone ahead and made it because making a project takes a while. So I'm just going to go ahead and open mine up. So when you open up your project, you are going to be shown this. In case you're new to Unity, we're going to get used to the UI. So right here in the middle is your scene viewer. So every game is made up of scenes. This is like essentially a screen that you edit. To navigate around it, you can use the scroll wheel to zoom in, zoom out. If you click the scroll wheel, it gives you a free move, like free camera move. There are alternate ways to do this, like oopsies. If you hold Alt while you click, that also works. And additionally, in the top left, there's a bar with these options. There's a hand tool, a move tool. If you hover over them, you can tell what they are. There's a rotate tool, scale tool, rectangular tool. Rectangular tool is just like drag and like select by dragging over them. But yeah, that's basically that. So anyways, below the scene view is we have the asset panel, and this is where all of the stuff in your game belongs. Here we see that whenever you make a Unity project, it'll automatically make a scenes folder, and in that scenes folder we have sample scene, which is what we're looking at right now, because a game has to have a scene to function. And then other than that, on the left, we have the hierarchy, which shows us what exactly is in our scene. It'll show us all of the game objects. Like right now, all we have is a camera. And then on our right, we have the inspector panel, which shows us the components of a game object, which are essentially their properties. There's a bunch of crazy stuff here, but we don't have to worry about that for now. But anyways, all right, now let's just get into it. So first thing we want to do, we're going to make a 2D platformer endless runner, and what we're going to need is a player character. And I have not prepared any assets for this because luckily Unity has some just like cheat ways to put in some assets. If you right click your asset panel, you can go to create 2D sprites and square. You can make all kinds of shapes, but let's go with square because that's like nice and simple. So we'll have a square. You can name it anything. I'll just leave it square, hit enter, and then boom, now we have a square sprite in our assets. And now we can drag this into our scene panel, and this will create a game object called square. For this one, we're going to change the name in the top right. You can click on it, and we're going to change it to player. So this is going to be what represents us. Let's put this tool. Okay, it's whatever. Anyways, so yeah, here's our player. But then also in the platformer, we need some terrain. So we're going to take the square sprite again, drag it in. And now this time, we're going to rename it, but this time we're going to call it ground. Oopsies. All right. And then here, look at the components. We have a transform, which is like the position, rotation. You can't really see that because that's that axis isn't available to us. But like Z, all right, yeah, you can rotate it. And we can scale it. And then down here in sprite renderer, we can see that here's the square sprite. And then we can change the color. Let's make it like a nice like brown or something like ground. The ground usually is. Okay, and then now it's a little small. Like we probably want the ground to be a little bigger, so we can click the scale tool, and with that we can move this little thing and scale it around. There are alternative ways to do this. You can also go in the top right in the inspector panel, and then you can just move this as well. But yeah, either way, we're just gonna let's go with just like a nice, just like longish thing like that, all right. And then we're just gonna move it around, and actually let's just center it. I'll just hit it with a 0, and then our player, we're gonna move our player a little higher up, and then there we go. All right. Now if you're up here, we have the play options. We have play, pause, and then if we play the game, our objects are in the scene. This is how our game looks. Also, another thing real quick, when you're playing your game, I think right here you'll have a thing called free, that says free aspect. This lets you decide the resolution of your game. I'd recommend you set this to like full HD, like 1920, 1080, because or even like 60:9, like either or, because like this aspect ratio is very common, so you should be designing with it in mind, you typically. But anyways, yeah, so also there's like a blue background there. By default, the Unity camera has a default background. You can also see what the scene looks like through here. But you can change this, because like, I know blue, I'll just like, it's whatever. I changed it a little, but like, it doesn't matter. You can just leave it how it is. Just like, if you want a different color, might as well. Okay, so anyways, our objects are in the scene, but they don't do anything yet. So here's where we're gonna start adding some actual like physics to our game. So right here on the right, once you click on player, we're gonna add a component right here, and we're gonna add one called rigid body 2D. Essentially what rigid body 2D is like, it's a physics controller. It controls the physics involved with our object. It like gives it physics at all. You can see here it gives the object a mass, a gravity scale. We don't have to worry about a lot of that right now. All we need to know is that it gives it physics. And now if we open up the game, you will see that our player falls down. They are now affected by gravity, but they went through the platform, and we don't want that. So how we're going to circumvent that is we're going to add another component, and this one is going to be called Box Collider 2D. Essentially what a collider is for people who play a lot of games, you might have heard the term hitbox. It's essentially like a hitbox. A box collider is a box that goes around, or it could be any other shape, but it's like, it is a box that goes around your game object, and it basically allows it to collide with other objects, and allows the engine to like know like when your thing is touching anything. So we're gonna put a box collider on it, and we're gonna put a box collider also on the ground game object. Also, something nice in Unity is when you add a box collider, it'll do its best to surround your object with it, so you don't have to worry about scaling it yourself. But now, if we open up our game and we play it, our box will fall down and it'll actually hit the ground, which is nice. Okay, now that we have all this set up, it's time to actually do some scripting, because our player can't actually do anything yet. So here is where a lot of the time you will spend like making a game will go. I don't even know what I was trying to say right there. But anyways, you're going to go add a component, and you're going to do new script. And we're going to make one, I'm going to call it player move. All right. And then once you have made the script, it'll show up, and now you can double click it and it'll open up your code editor. Alrighty. This might take a bit. Okay. All right. That was pretty fast. But anyways, okay. So now when you open this up, you'll see, I'll zoom this in. Or can I zoom this in? Let me see if I can get this a little bigger. Let me see. I don't know if that really helped that much. Weird. Whatever. Hopefully it's readable enough. Anyways, so yeah, when you open up a script in Unity, you'll get this little like set of things. The things we care most about right here are these two functions we get, these two methods. We get start and update. So start is called the moment the object is initialized. It's called only once. So this is where we want to do like a lot of initialization stuff. It's almost like a constructor in like typical coding. And then we have update, which is called every frame. This is relative to your computer, so it matches your frame rate essentially. And that's where a lot of our logic is going to go. So right off the bat, so first things first, we want to define some fields for our game object for our player. So we want this to be like a platformer. So we're gonna be wanting a movement speed and maybe like a jump height. So what we're gonna do is we're gonna write a public float speed and public float jump height. We're going to use these later to just calculate those, like how fast we're moving, how high we jump. And then we're going to do one extra thing. We're going to make a private rigid body 2D rigid. What this is essentially is it is a variable that's going to store a reference to our rigid body 2D that we attach to this game object, as we will need to manipulate it in order to like allow our character to move, because we were going to use the physics provided by it. So anyways, so in start, since this is during the initialization, we're going to take rigid and we're going to assign it the rigid body component that we put on using GameObject.getComponent rigid body 2D. Essentially what this is doing is its game object is referencing the game object that holds this script. Then it's getting the component, the rigid body 2D that is attached to this game object, and just assigning a reference to that to rigid. From there, now we're going to go into update, where we're going to actually mess around with things. So we want our player to move when we press left and right. So what we're going to do is we're going to do if input dot get key. There's a get key and get key down function. We want the get key as in, because get key down is it activates when you click something, right? Press the button down, whereas get key will continue to act while you have the key held down, and we want that. We want to be able to move while we're holding the key down. So we do get key, and this part's a little weird. Then we're gonna put in key code dot. Let's go with right arrow. So all right. So this is basically just saying like if it reads the input of you pressing right, the right arrow, we're going to now assign our rigid body a velocity. We're gonna do rigid dot velocity equals new vector 2 speed and rigid dot velocity dot y. Essentially what this is doing is we're accessing the rigid body and we're giving it a we're changing its velocity to this new vector. So in Unity, a lot of times we're going to be dealing with vectors, where just like the x and the y. So here we're going to give it a horizontal vector equal to our speed. So it'll be positive, so it'll be going to the right. And then when we're moving left and right, we don't want to alter our vertical movement. So we're going to just take the rigid body's current velocity in the y direction, so in the y-axis, so that we don't mess with it. So we're just going to just put it in there, just plug it in. So then this next part is going to be a little bit of copy and paste, because we can do basically the same thing for the left input. We're going to do else, and then we can paste in this statement to make an else if. And now instead of right arrow, we can change this to left arrow. And then instead of speed, we set to negative speed, so it'll go the opposite direction, but it'll retain everything else. And then finally, we'll have a final else statement. And so when you're not pressing any keys, we don't want to be moving. So we're going to set the rigid.velocity to a new vector 2 that is just 0, and rigid.velocity dot y. Okay. And then lastly, we want to add the ability to jump. So we're going to add a separate if statement. And here we're going to do if input dot get. Here we're going to use get key down because we just want to be able to jump every time we press it if we wanted to do it while you could do it also with get key, like with holding the space, like holding the jump button, but that would require some extra code, and we're kind of lazy, so this is like a lot simpler. So we're gonna do get key down, and we're gonna do key code, and we can do a classic one is like space, but you could also do, let's just go with up arrow for now. It's just like keep it consistent. Let's go up arrow. Oopsies. Oh, that was a little. Oh, I already made the brackets. My bad. So anyways, when we hit the up arrow, we're going to want to jump, and how we're going to do that is by doing rigid dot velocity dot. Oh no, not dot anything. My bad. Equals new vector to. And in this case, opposite to what we did before, we want to keep the horizontal speed. We don't want to touch it when we're jumping. We're just going to take rigid dot velocity dot x, and then we're going to change the jump. We'll set the vertical velocity to our jump height, essentially. I'm wondering this might be a little confusing because some people might be confused because in the live demonstration, I set these to key code like A, D, and space. I did like a WASD thing. This is just like maybe like easier to read, so that's why I'm going with this approach. But anyways, once we've all got this done, save your code, and then if we go back to our Unity editor, it will load up our script, and then you'll notice if you click on player and you go on the right inspector panel, you'll see that now where we had player move, we also now have the speed and jump height variables. That's just something really cool about Unity, is that it updates in real time. So if we added more fields, they would show up. You'll notice that the rigid field is not here because we set that to private. We don't want it to touch that, but we set these ones to public so we can edit them at any time. So right now, let's set these to like 5 and like 8. And then when you play the game, we should be able to move and jump. Just like that. And then something neat about Unity is while you're playing it, you can also edit these things. You can edit these properties and then play around with them. One thing to note, though, is when you exit play mode, they will return to the original. So make sure to keep track of what you've changed if you want to like keep those. But yeah, here we go. We got a nice like simple platformer. But if you're playing with this around a bit, you might have noticed that you can also do this. You can jump forever. And we don't want that. We don't want the player to be able to jump forever. That is a bug and not a feature currently. Although you could make it a feature, we're not going to make it here. So how we're going to do that is we're going to be able to stop this is by making a way for the game object to, or making the player able to check if it's touching the ground before it jumps. So how we're going to do this is we're going to go into the hierarchy on player. We're going to right click and we're going to create empty. This will create a child game object. And we're going to name this one ground checker, essentially. All right. And then with that, we're going to give it a box collider 2D. But yeah, essentially a empty game object. All it has is a transform. It doesn't have any other properties. It's essentially just invisible. But yeah, we're going to add this box collider to it. And then this box collider will try to wrap itself around the player. But we want this box collider to be somewhere else. So what we're going to do is we're going to hit this edit collider button. This will show 4 little dots around the game object. And by clicking on any of them, we can move any of the sides. So we're going to hit these, the top and the bottom ones. And we're going to bring them right below the player. We can also narrow the side ones if we'd like. This is not mandatory, but if you would like it to be a little less forgiving, you can do that. But anyways, once we've done that, now we have this nice ground checker. If we play it, you'll notice that now there's a gap between the player and the ground. That's because currently the box collider, just like a normal box collider, and like I've said before, it acts like a hitbox, and it's colliding with the ground and stopping everything. How we can circumvent that while still having the collider in existence is by setting this is trigger checkbox. By doing that, it no longer physically collides with anything, but it will still detect when it is like colliding with something, if that makes sense. It itself is not like physically like interactable, but it can detect collisions. This is useful in like games where you make like attacks and stuff without having like pushback or anything. But yeah, once we have that made, we're going to go back, or no, actually not yet. We're going to do one last thing. So, click on like your ground object. You can click on any game object, but let's click on the ground game object. And in the top right, there is this option called layer. And right now it's set to default. What we're going to do is we're going to click on the drag down, and then we're going to do add layer. There's a couple here. Don't worry about those. We're just going to do add layer. And then here we can like create our own layers. Make sure you're on layers, not sorting layers or tags, just layers. And on just like any available space, we're going to make a new layer called ground. Yeah. Once we've made that, we're going to go back to our ground game object and click the layer drop down again. And then this time we'll see ground is on it. And we're going to assign the ground layer to our ground object. Essentially what the layers are, it's like, if you've ever done digital drawing before or anything like that, the layers are just like a way to isolate certain objects. In this case, it makes it so anything with the ground layer is just part of this, it's like a bucket, essentially, of game objects. For now, though, this is the only thing with ground. So anyways, now we can go back to the code, and here we're going to do a couple things. We're going to now make a public box collider 2D ground checker. And what we're going to do with this is we're going to pass a reference to our the box collider that we just made. We're not going to do that in the Unity. We're not going to do that in the code. We're actually going to do that in the Unity editor later on. So stick with this for now. But anyways, we are going to use some code with it. In order to make sure that we also are able to tell if we're touching the ground or not, we're going to need to keep track of that with a boolean, or it's bool in this case. Private bool is grounded. This is just so how we can like keep track of whether or not we are grounded and can jump. So we're going to go down to input, update again, and then we're going to write some code to make sure we can keep track of when we are grounded or not. And how we're going to do this is we're going to do if ground checker dot is touching layers, and then here we're going to do layer mask dot get mask ground. This is a bit complicated, but essentially what this is doing is it's taking the collider we pass in and it's checking if it's touching certain layers, and then layer mask dot get mask is essentially it's taking all the game objects that have that are on the ground layer and it masks them out, so it like ignores everything else. When in this check, it only cares about objects with the ground layer, like on the ground layer. So we're gonna do that, and then in here, if it's touching it, that means we are grounded. So we want is grounded to equal true. And if we're not touching the ground, well, that means we're not grounded. So is grounded equals false. Okay. Okay, and then we need to make one extra check, or we're gonna make one extra edit, because now we have to make sure that if we are touching the ground, we are grounded, so we can jump. So now in the jump if statement, we're going to add an extra clause, where it's now it's going to be is grounded equals true, equals true. Technically, we could just write is grounded, but this is just like easier to read in case you're like new. But yeah, after you've done that, this code should be working. So now when we open up Unity again, we got one more step to do. We have to go to our player, and now if we go to the bottom, we'll see that we now have a ground checker field. We're gonna take our ground checker object while we have player selected, and we're gonna drag it into the box, and this will assign that box collider 2D to our player. And now if we open up our game, we should be ready to go. Yep, I can only jump once when I hit the ground. Well, all right, okay. Well, now that we have our basic flow down, our player is ready to go, now it's time to actually make some obstacles, because what's a game without a little bit of challenge, right? So what we're going to do is we're going to do that first step we did at the start, and we're going to take the square sprite down in assets, and we're going to drag it back into the scene. This time we're going to make this one we're going to name this one obstacle, and let's give it a more harmful looking color. Let's not like red. Red looks pretty dangerous. And similarly to the player, we're going to give this thing a box slider 2D because we want this to actually hit us. And we want to, and how an endless runner usually works is you're like, the player character will just move in this single platform or like single part in the middle, and then objects will just fly at them. So we want this box to move at our player. So how we're going to do that is, like the player, we're going to use a rigid body 2D. Yeah, so it's essentially that we're making another player object. And then we are going to make a script for this one, and we're just going to call this one obstacle. All right. All right. This script will be somewhat similar to the player. Well, actually, it'll be pretty similar to how we started the player script. We're going to make some fields, and of course, since this thing is moving, we want it to have a speed. So we're going to do a public float speed. And then, of course, like before, we also need to have a reference to the rigid body 2D. So we do private rigid body 2D rigid. Yeah, this probably looks very familiar. We did this a while ago. And then in the start, we're going to initialize rigid to be the game object's rigid body 2D. Something different this time, though, is we're not going to use the update method. We actually don't need it because we want this object to serve one purpose and one purpose only, just to move the moment it spawns. So what we're going to do is we're just going to use start, and all we're going to do is we're going to take that rigid, and we're going to set the velocity to equal new vector 2. And typically these things, we're going to have it go right to left, just because that's like how what people are typically like used to. So we're gonna have it go to the left, and we're gonna set this to negative speed, and then we actually don't care about its velocity vertically, so we're just gonna give it 0. We just want it to just go straight towards us. Okay, so now if we go back into the Unity editor, if we play the game, our guy just drops. Okay, there's actually two things I messed up on right here. So first off, we didn't give it a speed. So let's give it like 5, like our player. The second thing is you saw that it dropped immediately. It's because of the rigid body 2D. It obeys physics. But in this case, we actually don't want our obstacle to abide by all the rules of physics. We want it to just be an unstoppable force that just comes at our player. So what we're going to do is when you have the obstacle selected, we're going to go into its rigid body 2D, and we're going to change the body type here from dynamic to kinematic. So essentially what this does is dynamic is essentially like it considers all the physics, like everything around it, all that stuff, like collisions and whatnot. Kinematic makes it so that this thing, we can edit the object's physics, but it does not, it ignores everything else. Like it'll ignore collisions and whatnot. It only cares about itself. It doesn't care about gravity or anything like that. Just if you move it, it'll move. So once we have that set and we open up our game, our obstacle will move. But real quick, I want to show you guys something something that's a little weird. So if you jump at the obstacle, you will actually stick to it. And the reason for that is in Unity, whenever you create a game object, or I guess a box collider at all, you will have an innate like friction, a friction coefficient. And in this case, we don't want any friction. We just want our player to just slide off of everything. So what we're going to do is in the asset panel down below, we're going to right click, go to create, 2D, and physics material 2D. Once we've made it, you can name it anything. I'll just name it no friction. And you'll see in the top right that there is a set friction of 0.4, and we don't want that. We just want it to be 0. This way everything will just slide off and it won't get stuck. So now we set that, we're going to go back to our player, and in our box collider 2D, we're going to change the material to no friction. And then once that is done, we should be able to just jump at this and not get stuck. Okay. But then right there was another problem I forgot about. In player, see, when we got hit there, we rotated, and we don't want to rotate like that, especially when you're using like sprites and stuff. You typically want to stick to just one axis. So what we're going to do is go to the rigid body 2D in your player object, and then in rigid body 2D, near the bottom of the box, there is a constraints tab. When you expand that, you'll see that there's a couple options like freeze position and freeze rotation. We want the freeze rotation option, so we're going to check that. And now, when we play the game and we try to interact with him, we'll just bounce off, we'll just slide right through him, and we won't get like messed up in any way. Just like we want. We just want it to be just like them to be able to interact, but like we don't want anything to like break. Okay, yeah. So that is basically what we want. Okay. So now we're getting to the final bits of this game. So right now all we have is this one obstacle that moves around. But you know, where's the fun in that? We need some like variety. We need more of a challenge. It's just one thing. So what we're gonna do is, first off, we're gonna take the obstacle and we're going to drag it into our assets panel. What this does is it creates a prefab, which is a saved version of our object. It saves it to our project, and we can like create more copies of it at any time by easily just dragging it through. Like, we don't have to code any new ones. We just get to just drag them in. For now, I'm just gonna get rid of them. And then you can just delete it if you want, even, because we don't need it anymore. So that is exactly what I'm going to do. We don't need that anymore. But now that we have that saved, we're going to use that in some different ways. So what we're going to do first is we're going to create a spawner that will spawn these obstacles for us. And what we're going to do is we're going to, like before, we're going to go to the hierarchy, and we're going to create a new empty game object. And this one we're going to name spawner. All right. Something also nice about Unity is like when you make an empty game object, something nice that'll like help you visualize it is to the left there's this cube, and if you click on it, there'll be a drop down, and you can click on like any of these icons that just like shows you where the origin of your empty game object is, because they're essentially invisible otherwise. I typically like using like a red color because it's easy to notice. But yeah, we can just move around our spawner. But anyways, in our spawner, all we're going to do is we're going to make a new script, and we're just going to call it spawner. Okay, and double click it, and we're going to open it up. Now this code will be very, very short. Like the obstacle script, we do not need the update for this one. We're not going to use it. Instead, what we're going to do, so in the fields, we are going to pass in we're going to use a public game object obstacle. What this essentially is, we're going to give it a reference to our obstacle prefab, and it's just going to spawn it where the spawner is. So very quick and simple, we're just going to say instantiate obstacle transform.position quaternion .identity. All right, this is a little bit complicated if you've never seen this before. So instantiate is essentially it creates an instance of the game object that we pass in, which is obstacle, and it's going to initialize it at the transform.position, which is essentially the origin point of this current game object, in this case spawner. So it will spawn the obstacle game object at our spawner, And then quaternion identity is used for rotations. And by putting this in, it essentially just retains the original rotation of the instantiated game object. So in this case, because we don't want the spawn object to move at all, like it to be altered anyway. So that's basically it. And then once it's served its task of spawning the game object, we can just go ahead and destroy this thing. So we can do destroy game object. Oh, whoopsies. Yeah. And this will just wipe the spawner from your game. It's good whenever you're doing anything that involves making a bunch of prefabs. You should probably have some kind of case to destroy them. Or I'm actually going to add that real quick to the obstacle. So we want to make it so that the obstacle like disappears when it goes off screen. So let's look for, I'm just going to look for when it's off screen. It's like negative 10 is a good number. So what we're going to do is we're going to go into obstacle, and I guess we are going to end up using a void update. Like, my bad. I guess this step is kind of optional. You technically don't need to do this, but I think it's good to like prevent like lag eventually. And what we're gonna do is if transform dot position dot x is less than or equal to -10, destroy game object. This is essentially just if the thing goes this far to the left, it'll just destroy it. And from what I just saw, this is off the screen. But yeah, that is essentially that. So in the spawner, we can see now that there's a obstacle field, and we're gonna take our prefab from the asset panel and we're gonna drag it in there. And now when we open up the game, it should just spawn the thing, just spawn the obstacle. And if you look in the left, it should delete it right after it gets off screen, which is exactly what we want. Okay, now this is gonna be a little weird. So we're gonna take the spawner and we're going to turn this also into a prefab, because we are going to make a spawner that spawns spawners. That's very confusing, but I will explain. So what we're gonna do is we are going to make a first off, you can delete this now because now we have the prefab. We're going to make our last empty game object, and this one we're going to call pattern spawner, because currently all the spawner does is just spawns a thing that shoots and then it just that runs at us. But what we want is some variability. You know, maybe we want like multiple ways that it can spawn the obstacles, and that's exactly what we're going to do right now. So with pattern spawner, we're going to make one last script called pattern spawner. Yeah, just do add component, make new script, and we're going to call it pattern spawner. And once it's ready, just open it up. Okay. All right, and then yeah, now we're just here again. Okay, so how we're going to do this is we're going to need to create a collection of patterns that we're going to spawn into our game. And how we're going to do this is by creating a bunch of game objects, and then randomly going through some kind of data structure that lets us like pick them at random and then just spawn any given one. How we're going to do that is with an array. So we're going to initialize a public game object array called patterns. What else we need to worry about is how often we spawn the patterns, and how we're gonna do that is by having a public float called spawn rate. And when we're dealing with like time and whatnot, we should usually have a variable that keeps track of the current time. So we're gonna have a public float called current time, so that we can make sure we know exactly what time it is. So anyways, so in start, all we're gonna do is we're gonna set current time to equal 0. So every time we open up the game, it'll be set to nothing, and then we can start the timer as we intend to. So in update, how we're gonna do this is we're going to make it so current time is what's gonna keep track of the time between spawns, between the spawn rate and like yeah. So we're going to keep incrementing current time until it reaches spawn rate, and then so when current time exceeds or equal the spawn rate, that means we've hit the spawn rate and we will spawn something. I think I might have made that really confusing, but I'll just write it out. So we're gonna do current time. If current time is greater than or equal to spawn rate, first thing we're gonna do is we're gonna reset current time to 0. Because then it'll put the spawn on cooldown. And then after that, we are going to randomly pick one of our patterns. And how we're gonna do that is we're gonna select a random index from our array. So we're gonna do int index equals random dot range 0 patterns dot length. So yeah, this will grab us a number from 0 to patterns dot length, excluding this number. So like if we had like a pattern of we had 3 patterns in our array, an array of length 3, this would pick a number from 0 to 2. It excludes the last number. So now that we have that, we're going to then instantiate the random game object or the random pattern that we picked up. So we're going to do instantiate patterns at index, or yeah, at this index, transform dot position quaternion dot identity. Basically, whenever you use this instantiate, a lot of times it'll just have this like flow. The only thing that usually changes is the game object you pass in. Everything else is usually the same. There might be some cases where you manipulate some of them, but for now, I just do it like this. And so, anyways, otherwise, if current time does not equal spawn rate, it's not greater than, that means you want to increment it. So what we're going to do is do current time plus equal time dot delta time. So what this does is time.deltatime takes in the amount of time between frames on your computer. Because typically when you run things in update, it can get messy because I said this really early on, but like update runs once per frame, and that's based on the frames that your computer runs at. So if you have a computer that runs at 144 frames per second, it's going to do things way faster than a computer that has that runs at 30 frames per second. And how we can circumvent that and make our games more scalable and like work on more devices is by using time.deltatime, because it takes the like seconds between frames on your computer. So it ensures that like the same amount of time is taken by every device, essentially. Yeah. So by doing this, we're gonna make sure this runs on like everything. But yeah. By doing that, that should set up everything. And now we need to actually make our patterns. So how we're going to do that is, okay, I guess I lied, because we're actually going to make another empty game object. We're going to make a pattern game object. We're going to call this one pattern1. And this is kind of fun because now we're just going to get to just make a bunch of just random things. So we're going to take pattern1 and we're going to drag a spawner into it. This will just attach it here. Before I proceed, I'm going to go back to pattern1. I'm going to do the same thing we did with spawner and give it a icon. I'll give it like a blue diamond to differentiate it. But anyways, so we're going to move our spawner around, or our pattern around. And as you can see, the child object moves relative to it. So we're going to bring this over, maybe set to 0. Okay, so first things first, we're going to make one nice and simple pattern. I guess we can go with just one spawner for now. Just like simple, just a single box just going at the player. Very, very simple. But then yeah, once you like a pattern, we're going to take that pattern and we're going to drag it into the assets to make it a prefab. And then this will get a little repetitive, but then we're gonna keep doing this essentially. So I'm going to duplicate this. I'm going to delete the old one. And now I'm going to mess around with this one. I'm going to add in another spawner. Move this one back over, and I'm going to do like a box above. Maybe like a nice like narrowish window maybe. Okay, like this maybe. Okay. If I like that, I'll drag that in. If you get this message, you're going to want to make a new original prefab. We don't want to like mess around as like a variant. And then I'll probably make one more pattern. I'm going to duplicate the old one, delete the, or I'm going to duplicate the old one, delete it. And then with this new one, I'm going to add one more spawner. And this one I'm gonna make a little bit of like a cooler shape or something. I'll make like a weirdish staircase. Okay, yeah, that should be neat. Okay. And then with that one, looks good. I'll drag that into here, make it original. And then once you're done with that, just delete them all. Go back to your pattern spawner. I forgot to give this one an icon. I will do that also. Go to your pattern spawner, move it a little off screen so that they can spawn over there. And then over here in the inspector, we have our patterns array, but it currently has an array size of 0. We can set that to now 3. Hit the drag down, and now we have space for 3 game objects. We're going to put in those 3 patterns we made. So pattern 1, I guess pattern 1, 1, and pattern 1, 2. And then we need to set a spawn rate. Let's go with like 1.5 seconds. Technically, we could also have current time as like a private, because we honestly don't need to change it. But anyways, with that all set, when you hit play, we should have a functioning game. But yeah, here we go. It's spawning the cubes at me. Oh, they're coming in different. Oh no. Oh wait, there's one more thing I need to do. I forgot to set the obstacles to have the ground layer, because currently when I jumped there, I got stuck on the boxes because I could not jump over them. Because with how our code is functioning right now, we have to check that we're touching something that's in the ground layer. So what we're going to do is we're going to go to the obstacle prefab and change it to ground. But yeah. Well, something also neat is that, what's cool about the prefabs is since they're like a saved copy of the game object, every time you make one, if you want to edit some kind of property about it, you can go to the prefab by double-clicking it, just like mess around with it, like maybe like make it a little like taller, make it a little wider, and then when we run the game, all of this applies to all the copies of this object. So very customizable, and now I can jump on the boxes and I can jump off of them, and yeah, there we go. We have a nice, simple, endless runner. If we wanted to further expand this game, we could add like an actual lose condition. Maybe we could add like a way to keep track of score and whatnot. But this is essentially what I covered in the live demo. So that's where I'm going to cut off for now. But if anybody would be interested in more, just like feel free to ask me. But yeah, that is essentially that. But yeah, thank you for sticking with me. I might have gone a little fast. Sorry again for like messing up the recording and all that. But yeah, thank you guys for listening. And I hope you guys learned something cool. And I hope you guys learn how to make a game. But yeah, see you guys around.